So I'll be covering some of the topics about the TIM tester, specifically based on the ASTM D5470. Talking more about the instrument itself and also the direct outputs and what kind of the typical value you can get from this type of measurements. So first of all, showing your screen right there is the ZFW TIM tester. You can see that there is that hot plate, cold plate type instrumentation right there. The TIM tester is a steady state method. It's a contrast to what we've been showing here, where we're focusing a lot on the transient methods. And another big contrast, fundamental contrast really, is that the TIM tester's main output is typically the thermal resistance, impedances, and the conductivity is typically calculated after the fact. Another thing is that thermal conductivity that are reported are typically apparent thermal conductivity or effective thermal conductivity, more so because of the nature of the method itself. There is thermal contact resistance that exists between the TIM's interface between the hot plate, cold plate, and the bulk material itself. So one of the quick highlight that I would like to cover with the ZFW TIM tester itself is this unique capability when it comes to measuring the thickness itself. So when most TIM testers out there commercially uses some sort of a gauge, the ZFW TIM tester uses a optical method in order to have this high resolution, high accuracy type of thickness measurements. And that would usually output into a high resolution, high accuracy thermal conductivity based on the thermal resistances and impedance measured. The specifications are all mentioned in this page right here, but I'd like you to kind of like focus on the fact that, we can measure this all the way to about 1 micron if need be using this technique. So right there, that's the video playing right now. So you can see here, we're testing a paste between those hot plate, cold plates. And what will be shown in a bit right here would be the camera or the optical method that I've been mentioning. And how this camera is measuring is that it monitors the shadow between the bar located by the hot plate, cold plate. This is the typical UI right here. You can see that the bond line thickness is currently measuring at 17 micron with this particular paste that we're testing. And we're doing a cyclical testing where we're applying low pressure, high pressure, so going up and down right there. And you can see the change of the apparent thermal conductivity and the thermal impedances as a function of that change in pressure. And this is just the direct output of the uh, camera itself. So that would be what I would say, a typical run for some of our TIM testing done in-house.